This video is about graphing transformations where we're going to write the equations. So a couple of things to remember from yesterday. If we are adding or subtracting a number, that controls moving up if it's plus on the outside and down if it's a minus. If the number is inside parentheses, that controls our movement to the left and right. So we move to the right if it's a minus, and we move to the left if it's a plus. If it's being multiplied by 1, that's when we are going to reflect over the x-axis. So remember that we can determine a shift of a graph based on the changes made to the parent function. The equation f of x equals x squared is called a parent function. This is our original graph, and then we're going to make changes to it. So here's a bunch of examples of other parent functions. We're going to focus on the ones that have exponents with them. So looking at some examples for how we write a shift change. Describe the change to the graph. So remember that f of x plus k moves our graph up or down k units. So if we have f of x equals x to the fifth plus 9, this plus 9 is telling us that we are going to move up 9 units. Number 2, f of x equals x squared minus 15. The minus 15 tells us that we are going to go down 15 units. Notice that the exponents change. The first one was an x to the fifth, the second was an x squared. That doesn't change how our graph shifts. It just changes the shape of the graph. Remember that f of x minus h moves our graph to the right or to the left h number of units. So in number 3, we have f of x equals parentheses x minus 3 to the fourth power. This minus 3 tells us that we are going to move right 3 units. Remember that our original function has minus h. That's why it's a right movement. The second one, f of x equals parentheses x plus 9 squared. This time it's a plus 9. So this means we are going to move left 9 units. Remember that the last type of shift is what happens when we multiply by a negative 1. When we multiply by a negative 1, we are going to reflect over the x-axis. So here this is a reflection over the x-axis because this became a negative. So let's take some functions and change them given our shift or reflection. So in number 6, given f of x equals x squared, shift the graph right 3 units. So if we're moving right, that means we're going to be in the parentheses still. So we have f of x equals, we're going to have a parenthesis with our x because we are moving right 3. That's a minus 3 in parentheses. Because there was this squared power given to us, we're just going to add the square outside our parentheses. Number 7, given f of x equals x to the fourth, reflect over the x-axis. Remember when you reflect over the x-axis, we multiply by negative 1. So we have f of x equals negative 1 times x to the fourth. We don't need parentheses because we're not moving left or right. Number 8, given f of x equals x to the fifth, shift the graph up 7 units. So we have f of x equals, we leave x to the fifth because we're moving up 7, so we're going to add 7 at the end of our equation. Number 9, given f of x equals x to the third, shift the graph left 5 units. So remember, a left 5 is a plus 5 inside the parentheses. So f of x equals parentheses x plus 5, and then our little exponent goes outside the parentheses. So anytime there's a left or right movement, the number must go outside the parentheses. Number 10, given f of x equals x squared, shift the graph down 1 unit. So we have f of x equals x squared, down 1 is a minus 1, so outside we would have minus 1. 11, 12, and 13 have 2 movements in them. So In number 11, we need to shift right 3 and down 4 units. So we have f of x equals, remember that right 3 means minus 3 inside the parentheses, and down 4 is a minus 4 outside of parentheses. So we would have x minus 3. We need our power to the 4th power, and then minus 4 because we're going down 4 units. Number 12, given f of x equals x to the 5th, we're going to shift left 5, so that's going to be a plus 5 in parentheses, and then a plus 1 outside parentheses for the up 1. So we have f of x equals, parentheses, x plus 5. We have our power to the 5th outside the parenthesis, plus 1. Our last one, number 13, f of x equals x to the 3rd. Shift the graph right 5 and up 9. So right 5 is a minus 5 in parentheses, and up 9 is a plus 9 outside parentheses. So we have f of x equals, parentheses, x minus 5 cubed, because we had a cubed power here, plus 9. So a couple of things to remember: that the exponent never changes. Remember that left and right movements happen inside parentheses and up and down happen outside parentheses. Also remember, when you are reflecting, you put a -1 in front of your x.